Hey guys, welcome back to Click Code. Today we're doing another Brainstellar Quant puzzle. This one is called Father of Lies. It's an easy problem of probability type. So just to tell you guys what's going on in the problem, it's basically a problem based on conditional probability, where we've been given a few conditions and the probability for those events, and we have to deduce the probability for a certain event. Just to note down the main points that have been used in this problem, it's using conditional probability, the formula that probability of A given B is the probability of A intersection B upon the probability of B. Hope you guys know about this theorem. There's also another theorem that is in play over here, which is also known as Bayes' theorem, and it states that the probability of A given B is the probability of, well, it's actually this formula, but over here we say that the probability of B given A into the probability of A is the same as the numerator. So this is how we write down the Bayes' theorem. And the probability of B over here can be broken down usually into subparts. And another hint I'd give you guys is just to tell you guys the line that, and this is pretty famous when it comes to conditional probability, that you guys have to understand that whenever we have been given additional information, that changes the probability of a certain event occurring. So we'll be going over two solutions. Now, coming to the first solution, which is, in my opinion, the more mathematical and like academic way of solving this problem. It is using Bayes' theorem. So just to lay down a few of the things that we have been given. So let's first focus on this line over here, that the first order, and we're assuming that whatever the first order and the second order says is completely true. So the first order tells us that the probability of snowfall on a particular night is 1 by 8. And I'll be denoting the event of snowfall as S, right? So this line over here tells us that the probability of S is 1 over 8, right? And the second line, the second order tells that 5 out of 6 times the father is lying. Now, I'll denote the event of the father lying as just LIE. So basically, the probability of LIE or lying of the father is 5 by 6, right? Now, what does this mean? First of all, you guys might be a bit stumped by this line over here. This basically means, and so I'll be denoting the event of the father claiming there to be snowfall as a tick mark, and the father claiming there to be no snowfall as an arrow. So what this means is the probability of getting a tick mark given it does not snow. So, and I'm denoting not snowing by S bar, right? This is equal to, now what is this? So the father is claiming that there was snow given there was not snow. So this is basically the problem. This event is basically the father lying. So this has the same probability as this over here. So this becomes 5 by 6. And this also means that the probability that the father claims there to be no snowfall, given there was snowfall, actually is also 5 by 6. So this is what the probability of lie means, right? Again, you guys should understand that what I mean by a tick mark is the father claiming there was snowfall, and what I mean by a cross is the father claiming there to be no snowfall. And in the end, what is asked of us is what is the probability that there were actually snowfall on that particular night. So we could denote that as the probability that there was actually snowfall given the father claims to there have been snowfall the last night. So this is the value that we have to calculate over here. Now, how do we go about this? Again, we use Bayes' theorem, pretty standard. So I've just mentioned all these points over here again. So again, we have to use the Bayes' theorem to solve this problem. So we've been asked the probability of S given that the father does claim there to be snowfall. So just to write down the formula, that would look something like this. And now let's also expand the probability that the father claims there to be snowfall. So that would now look like this. And just to explain this part a bit, so the probability that the father claims there to be snowfall can be broken down into two subcases, right? Either there was snowfall, and then the father claims, so the father saying the truth, and he claims there to be snowfall given there was actually snowfall, or there wasn't snowfall, and the father's lying and he claims there to be snowfall given there wasn't actually snowfall. So that is denoted by this over here, and both of these cases are mutually exclusive, and both of these cases add up to create the total event. So that's why we've added them over here. So now it's just a matter of plugging in the values that we have over here. So once we plug in these values, we get an answer of 1 over 36. So this is our final answer for the probability that there was actually snowfall given the father claims there to be snowfall. Now I'll also be talking about the second solution, the second way of going about this problem. And so this second solution really like tries to emphasize the fact that when I say that we get additional information, that changes the probability of a certain event occurring. Now this happens because additional information changes the sample space for the event. Now what do I mean by this? Let me try to elaborate. Now imagine there were 48 different days or 48 different test cases. Now where did I get this number 48 from? Well, since one of the probabilities is 1 by 8 and the other is 1 by 6, so just to make sure that I'm including every single case that could have happened, I've just done 8 into 6 and I got 48. And you'll understand why I did this in a few minutes. I assume there to be 48 total days or 48 different cases that would have been possible. Now, we've been given that the probability, so the first thing is that the probability of snowfall is 1 by 8. Now, what does this mean? That means out of our 48 cases or out of our 48 sample space, we could say that there is snowfall on 6 days and there is no snowfall on the other 42 days, right? And now another thing that has been given to us is that the probability that the father lies is 5 by 6. Now what does that mean? That means that for the 6 days that when there is actually snowfall, the father is going to claim there wasn't any snowfall 5 out of the 6 days, and he's going to say that yes there was. He's going to say the truth that there was snowfall on 1 or out of these 6 days. And for this case over here, when there wasn't any snowfall, so 42 into 1 by 6 is basically 7. So on 7 days, he's gonna say the truth that there wasn't any snowfall and on the other 35 days, he's gonna be lying and saying that there was snowfall, where it didn't actually snow, because we're talking about S bar over here. But since the probability of him lying is 5 by 6, so out of the 42 days, I did 42 into 5 by 6. That gave me 35. We know that for the 35 days out of the 42 days that there wasn't any snowfall, he's going to lie and claim that there was snowfall. We can deduce, or we can simply just see by the map the probability of there was actually snowfall given the father claims there to be snowfall. Now what does this mean? Now since the father has claimed to there have been snowfall the last night, we know that our sample space is just this part over here, the 35 days over here, and this 1 day over here. This part and this part are removed from our sample space because these two cases can't even happen anymore, because we have been given that the father does claim there to be snowfall. And among this new sample space, we have to tell the probability that it did actually snow, which is just 1 day out of these total 36 possible cases. So this gives us the exact same answer of 1 over 36. I hope you guys understood this type of solution, and thanks for watching.